This is AJH welcoming you to the Edexemy YouTube channel. In this episode, we are going to see the next part of the Matrices Class 12 Higher Secondary second year. Come, let's see.
Now we are into the green board. Now we are going to find the inverse of the following. Three matrices are given. One by one we will find the inverse. Now how to find the inverse? How to find the inverse of the following matrices? We will take the first matrix. We will take all these matrices as A. This A to the power of minus 1. If we write like this, this means A inverse. The formula is 1 by determinant of A into adjoint of A. This is the formula you have to remember. Okay, A inverse is equal to 1 by determinant of A, adjoint of A. We have to find first determinant of A, then adjoint of A. Then if you multiply the reverse, inverse of the determinant value into adjoint of A, we will find A inverse. Now we will take this matrix as A. Therefore A is equals to minus 2, 4, 1, minus 3. Okay. Now will first step is to find the determinant value of A. 3 minus 3 into minus 2 is 6, minus into minus plus 3 into 2 is 6. Minus of 4, 1 into 4 is 4, therefore 2. This is not equal to 0, this is above 0, this is not equal to 0. If this is equal to 0, then the said matrix is a singular matrix. A inverse does not exist for singular matrices. This determinant value must not be equal to 0, then only A inverse exists. If it does not equal to 0, then A is called non-singular matrix. A inverse exists only if A is non-singular. You have to write this. A inverse exists only when the given matrix is a non-singular matrix. If the determinant value will be 0, then it is a singular matrix. There is no inverse of that matrix. If it is singular, no inverse exists. If it is a non-singular matrix, then only A inverse exists. So the first step, you have to find the determinant value and prove that it is not equal to 0. Then you proceed to find the inverse of A. A inverse exists only if A is non-singular. This is a very most important step, you should not forget. Okay. First to prove it is not equal to 0, then you proceed on to the next thing. Now we have to find the adjoint of A. Now how to find the adjoint of a 2 by 2 matrix? It is very easy. We have already discussed, you know. Now we will find the adjoint of A. Okay, we will find adjoint of A. How to find adjoint of A of a 2 by 2 matrix? Simply the cross diagonal, this diagonal you interchange the numbers, and this diagonal you change the sign, that's all. Now you follow me. 2, 3 will become minus 3 here, minus 2. Interchange the numbers and the sign will change in this diagonal. 1, 4, minus, minus, plus become minus, minus become plus. These are the two things you have to memorize to find adjoint of a 2 by 2 matrices. Okay. Now we will find A inverse. Now by formula you have to put determinant value here 1 by, what is the determinant? 2. Therefore 1 by 2 into adjoint of A. What is the adjoint? Minus 3, minus 3, minus 4, minus 1, minus 2. Okay. This is the value of A inverse, inverse of A. Okay. We take minus outside, then minus will become plus, plus will become minus, 3, 4, 1, 2, the answer. Now we will find the next second problem. Take A is equals to 5, 511, 151, 115. Okay. Okay, like that we will take first step. As usual, we will find the determinant value of A, prove that it is not equal to 0. Okay. Now expanding through R1, you have to write here the step in the exam, you have to write here expanding through R1, expanding through R1. Now you will get 5 into leave that row and column, and you will get 5 into 5 is 25, minus of 1 into 1 is 1. Okay. So the next thing you put minus here, then 1 here, you leave that row and column where the 1 lies, you will get 1 1 1 5 as 5 into 1 is 5, minus of 1 into 1 is 1. Okay. Okay, plus minus will become plus here. Okay. Now for this you leave that row and column. Now 1 into 1 is 1, minus 1 into 5 is 5. We will simplify this. 5 into 25 minus 1 is 24. Therefore 5 into 24, minus of 5 minus 1 is 4. 4 into 1 is 4. 1 minus 5 is minus 4. This will become minus 4. Now what is 5 into 24? 120 minus 8. This will be 128. 120 minus 8 is 112. Okay, this is the determinant value of A, which is not equal to 0. Which is not equal to 0. Therefore A inverse exists. You have to write, since A is a non-singular matrix, therefore A inverse exists. You have to write in the exam. Since A is a non-singular matrix, therefore A inverse exists. Okay. We will find adjoint of A. What is adjoint of A? Okay. Now you know how to find adjoint of A. We will move the board little upwards. Now this A, you have to find the adjoint of A. You know how to find. First the sign value, you put plus sign here, then you leave that row and column. What is the determinant? 5115. 5115. For the next minus, plus will become minus 1. 1 you leave that row and column. You leave that row and column. The remaining numbers will form the determinant of 1115. Okay. The next plus sign, minus will become plus. You have to leave that row and column. You will get determinant of 1511. Okay. Now we will find for all these elements similarly 1 here, minus, plus will become minus. Here you leave that 1 which is in the row and column, you will get 1115. 1115. Okay, next plus, minus will become plus, determinant of the 5. Leave that row and column, you will get 5115. 5115. Okay, the next minus, it will become, then you leave that row and column, then you will get 5111. 5111. Okay. Now minus will become plus, determinant of, leave that row and column, you will get 1151. 1151. Okay. Next plus will become minus, determinant of, you leave that row and column, you will get 5 1 1 1, 5 1 1 1, plus will become minus will become plus, determinant of, you will leave the row and column 5 1 1 5, 5 1 1 5. You know all these things now. By this time you will be familiar with all these things. And the transpose of this matrix is cofactor matrix. You have to find the transpose, then only this will become adjoint of A. You should not forget to put T. Okay. Now find the determinant value. Simplify this. 5 into 5 is 25 minus 1. 25 minus 1 is 24. Okay. 5 into 1 is 5. 5 minus 1 is 4. Minus is outside. Therefore, you put minus 4. Okay. Here 1 into 1 is 1. 1 minus 5 is minus 4. Similarly, here one minus is here, therefore 5 into 1 is 5, 5 minus 1 is 1, 4, 5 minus 1 is 4. Here 5 into 5 is 25 minus 1 is 24. Here minus is here, therefore put minus here. 5 into 1 is 5, 5 minus 1 is 4, 4 minus 4. Here 1 into 1 is 1, 1 minus 5 is minus 4. Here minus is here, therefore 5 into 1 is 5, 5 minus 1 is 4. Now here 25 minus 1 is 24. Therefore, you have to find the transpose of this matrix to get adjoint of A. So, the next step, adjoint of A. Adjoint of A is equals to, change the column into rows. 24 minus 4 minus 4, you put it as a row. 24 minus 4 minus 4. Okay. Take the next column, minus 4, 24 minus 4. You write at the second row. Minus 4, 24 minus 4. Now take the third column, write it as third row. Minus 4 minus 4, 24. Minus 4 minus 4, 24. Now this is the adjoint of A. Here if you notice, 4 is common in all these numbers. Take that 4 outside. If we take 4 outside, 24 will become 6. 6 into 4 is 24. Minus 4 will become minus 1. Minus 1 into 4 is minus 4. Similarly, you write for all the other numbers. All the other numbers. Minus 4 minus 1. Minus 4 minus 1. Minus 4 minus 1. 24 will become 6. So, this is the adjoint of A. Okay. This is the adjoint of A. Now, we will pass on to find the inverse of A. Now, we substitute all these numbers in the formula. Now, what is the formula? A inverse is equals to 1 by determinant of A into adjoint of A. This is the formula. Okay. Now, to substitute the values of determinant, adjoint, everything, 1 by, what is the determinant value? What is 112. Now, this adjoint, we will put it here. Therefore, 6 minus 1 minus 1 minus 1 6 minus 1 minus 1 minus 1 6. Okay. Okay. Now, 4 and this 112, this answer is, how many 4s are there in 112? You will get 28. Therefore, 1 by 28. There are 28 4s in 112. Therefore, 1 by 28, the same thing. 6 minus 1 minus 1 minus 1 6 minus 1 minus 1 minus 1 6. Now, this is the answer of A inverse. Okay. Now, we will pass on to find the third one. Third matrix. For this matrix, we will find A inverse. The first step will be determinant of A. You take this matrix as A. Okay, this matrix as A. Therefore, You will write all these things in the exam. Take A as this matrix, though we will straight away pass on to find the determinant value of A. Okay, what is the determinant value of A? Now expanding through R1, you have to write all these things. Expanding through R1, 2 into 4 into 2 is 8 minus 7. 8 minus 7. You know how to find the determinant value. Minus of 3 into. You leave that row and column. Now 3 into 2 is 6. 6 minus 3. Plus 1 into. Plus 1 into. Leave that row and column. 7 into 3 is 21. 7 into 3 is 21 minus 12. 3 into 4 is 12. Now 8 minus 7 is 1. 1 into 2 is 2. Now here 6 minus 3 is 3. 3 into 3 is minus 9. Minus 9. Now 21 minus 12 is equal to 9. Therefore plus 9. Plus 9 and minus 9 will get cancelled. We will get 2, which is not equal to 0. Therefore the matrix A is non-singular matrix. Therefore inverse of A exists. You have to write all these things. You have to first find the determinant value and prove that it is not equal to 0. If it is not equal to 0, then only we can calculate the A inverse. You have to write, since A is a non-singular matrix, A inverse exists. Now we will pass on to find adjoint of A. It's the same procedure. Now first you assign the plus or minus here. You put plus first. You start with plus, then leave that row and column. 4 into 2 is 8. 4 1 7 2 determinant. Okay, next minus 3. You leave that row and column. You will get 3 1 3 2. 3 1 3 2. Okay, then you put plus determinant of. You find the cofactor of 1. 3 4 3 7. Now cofactor of 3, you find plus will become minus here. 3 1 7 2 minus here. Okay, plus minus plus minus. Then this value is plus. Plus second 4. Leave that row and column. You will get 2 1 3 2. 2 1 3 2. Okay, next minus determinant of. You leave that row and leave that column. You will get 2 3 3 7. 2 3 3 7. Okay, now here plus determinant of. Now for this 3, you find, leave that row and column. 3 1 4 1. 3 1 4 1. Okay, plus will become minus determinant of. You leave that row and leave that column. You will get 2 1 3 1. You will get 2 1 3 1. Okay, now plus final one. You leave that row and column. You will get 2 3 3 4. 2 3 3 4. Okay, now you have to find the transpose T. Don't forget to put T. Now we will simplify this and get the value of adjoint of A. We will move this, and now here what will be the 4 into 2 is 8. 8 minus 7 is 1. 4 into 2 minus 7. Next minus 3 into 2 is 6. 6 minus 3 is 3. Therefore minus 3. Similarly, you will get 7 into 2 3 is 21 minus 12. 21 minus 12. 9 is the answer. Okay, here minus of 3 into 2 is 6. 6 minus 7 is minus 1. Minus into minus plus 1. Now here 2 into 2 is 4. 4 minus 3 is 1. here 7 in here minus 1 minus is here, therefore 7 into 2 is 14, 14 minus 9, 14 minus 9 is equal to minus of 5. Okay, now we will come here, 3 into 3 is 3, minus 4 is equal to minus 1, here 1 minus is here, 2 into 1 is 2, minus 3 is minus 1, minus into minus plus, therefore plus 1. 4 into 2 is 8, 8 minus 9 is minus 1. Therefore, you have to find the transpose. Transpose, put, don't forget to put T here. Now, to find adjoint of A, you have to change the column into rows. So, now first column you take 1, 1, minus 1. You write it as a row. 1, 1, minus 1. Okay. Similarly, second column you take minus 3, 1, plus 1. Similarly, the third column 9, minus 5, minus 1. Now, this is the adjoint of A. Now, we will finally calculate A inverse. Now, what is A inverse? Okay. A inverse is equals to 1 by determinant value we have already calculated, it is 2, put 2 here, and the adjoint of A, 1, 1, minus 1, minus 3, 1, 9, minus 5, minus 1. Therefore, this is A inverse, proved. Okay. Now, we will pass on to find another problem. See, f of alpha is equals to cos alpha 0 sin alpha 0 1 0 minus sin alpha 0 cos alpha. Then show that f of alpha to the power of minus 1 means inverse of f of alpha is equal to f of minus alpha. F of alpha, the inverse of f of alpha is equal to f of minus alpha. Now, how to find this? First, you will find the determinant value and show that the inverse exists. Now, f of alpha, find the determinant value. Now, expanding through R1, expanding through row 1, you will get cos alpha into 1 into cos alpha is equal to cos alpha, and here 0 into 0 is 0, therefore, you need not put it. Next, minus of 0 into anything is 0, therefore, third plus sin alpha. Sin alpha, you leave that row and column, you will get 0 into 0 is 0, minus of minus sin alpha, minus into minus plus, you will get sin alpha. Now, simplify this, cos alpha into cos alpha is equal to cos square alpha, minus 0 you leave it, sin alpha into sin alpha is equal to sin alpha into sin alpha, sin alpha into 0 is 0, sin alpha into sin alpha is sin square alpha. Now, sin square A plus cos square A is equal to 1. So, trigonometry formula, no? Therefore, cos square alpha into sin plus sin square alpha is equal to 1, which is not equal to 0. Therefore, the inverse exists for f of alpha. Sin square A plus cos square A is equal to 1 is a trigonometry formula you would have studied in the 10th class. Therefore, 1 is above 0. Now, we will pass on to find adjoint of f of alpha. What is adjoint of f of alpha? To find the inverse, we have to find adjoint of f of alpha. Now, plus, assign the number, leave that row and column, you will get the determinant of 1 0 0 cos alpha. Now, for the second one, 0 you leave it as 0. For 0 you leave the row and column, you leave the row and column. You will get 0 0 minus sin alpha cos alpha. Now, the third one plus, for this sin alpha leave that row and column, you will get 0 1 minus sin alpha 0. Okay. Okay. Okay, put the determinant symbol here. Okay, we will find this for 0. You leave that row and column, you will get minus here, leave that row and column, you will get 0 sin alpha, 0 cos alpha. Okay, 0 cos alpha. Now minus will become plus, minus will become plus, therefore you leave that row and column, you will get cos alpha sin alpha, cos alpha sin alpha, minus sin alpha cos alpha, minus sin alpha into cos alpha. Now the next one, plus will become minus, the plus will become minus, you leave that row and column, cos alpha 0 minus sin alpha 0. You have to put a minus here, so minus will become plus, will become minus, then you put a plus here, then for the last row, you leave that row and column, you will get 0 sin alpha 1 0, then you put minus, then here for this leave that column and row, you will get cos alpha sin alpha, cos alpha sin alpha, and then here it will become, you leave this row, this column, you will get 0 0. Okay, you get 0 0. For the final one, you leave that row and column, you will get cos alpha 0 and 0 and 1. Okay, 0 and 1. Now this is the cofactor matrix, you have to find the transpose. Okay, now we will simplify this, we will move upward a little bit. Now we will simplify this. This is equals to, now cos alpha into 1 is equal to cos alpha minus 0. Here 0 0, so if you cos multiply, you will get 0. Then here 0 into 0 is 0, minus of minus plus, therefore sin alpha. Now 0 0 here, if you cross multiply, this will become 0. Here cos square alpha, minus of minus plus sin square alpha, cos square alpha plus sin square alpha is equal to 1. Here 0 0 it is coming, so if we cross multiply, everything will become 0, and one minute, or just a minute. Now for this third row, 0 into anything is 0, then 1 into sin alpha is equal to minus sin alpha. Okay, minus sin alpha. Now this one is equal to 0, this one cos alpha. So for this cofactor matrix, you have to find the transpose, then it will become adjoint of A, adjoint of f of alpha. Okay, adjoint of f of alpha, change the column into rows, we will get adjoint. Cos alpha 0 minus sin alpha, you write it as a row. Cos alpha 0 minus sin alpha as a row. Okay, the next column you write it as a next row, 0 1 0. The next one is sin alpha 0 0 cos alpha. This is the adjoint of f of alpha. Now we will find inverse of A. Now what is the inverse of A? Inverse of A. Inverse of A. F of alpha, the inverse of f of alpha is equal to 1 by determinant of f of alpha into adjoint of A. A here is f of alpha. Therefore, we have already calculated this f of alpha determinant value is 1. Therefore, 1 by 1 is 1. We can leave it. Therefore, the adjoint of f of alpha becomes the inverse of f of alpha. Cos alpha 0 minus sin alpha 0 1 0, sin alpha 0 cos alpha. Now the problem is now almost finished. Now what is f of minus alpha? Now in f of alpha, wherever you find alpha, you put minus alpha. You substitute minus alpha instead of alpha in the given problem. What is the given problem? Cos of alpha. So f of minus alpha means cos of minus alpha. You put 0 here. Here sin of alpha will become sin of minus alpha. See, in the given problem, you have to put minus alpha in wherever alpha is there, then you will get like this. Now this is equals to cos alpha. Cos of minus alpha will be cos alpha. Since cos is a even function, cos of minus theta is cos theta. This is a trigonometry principle, trigonometry theorem. Cos of minus alpha is cos alpha. Therefore, cos of minus alpha is cos alpha. Since cos is a even function, sin is an odd function. Therefore, sin of minus theta is minus sin theta. Sin of minus theta is minus sin theta. Therefore, minus sin alpha will come here, since sin is a odd function. Here 0 1 0. Here sin of minus alpha is minus sin alpha. Already one minus is here. Therefore, you will get sin of alpha. 0 here. Then you have to put cos of minus alpha here. Here you put cos of minus alpha. Okay, cos of minus alpha. This you change it into minus alpha. Wherever alpha is there, you have to put minus alpha. Therefore, here also you have to put minus alpha. Cos of minus alpha is cos alpha. Okay, now this is the f of minus alpha. Now you compare 1 and 2. If you compare 1 and 2, both are same. Therefore, the inverse of f of alpha is equal to f of minus alpha. You see both the answers are same. Therefore, f of alpha inverse of f of alpha is equal to f of minus alpha, proved.